To an empty scene, add a raycast 3D node and rename it laser. Then to this, add a child mesh instance 3D and rename this beam mesh. Add a cylinder mesh to the mesh property of the mesh instance 3D. Then set the top and bottom radius to your desired size and set the height to any small value. Add a standard material 3D to the surface material override. Set transparency to alpha. Under albedo, set the color of your mesh to the desired color, making sure the A value is around 215. Then enable emissions and set the emission color to the same color as you set above. Then set the energy multiplier to 10. Save the scene as laser and then add a script called laser to it. Create an onReady variable called beam mesh and get a reference to the beam mesh child. In the process function, add the variable called castPoint and call the function forced raycast update. Underneath this, create an if statement which checks the isColliding function. In the if statement, set the local collision point to the castPoint variable. Then set the mesh height of the beam mesh to the y value of the castPoint and set the y position of the beam mesh to half that of the castPoint's y value. Create an empty scene with a node 3D as its base and rename it to main. To this, add a mesh instance 3D and rename it floor. Add a plane mesh to this and resize it to 5x5. Save the scene under main. In a new scene, add a mesh instance 3D as a base and set the mesh to box mesh. Set the size of this box to 0.5 in all dimensions. And rename the mesh instance 3D to box. Add a static body and a collision shape 3D as a child and save the scene as box. In the main scene, add 2 instances of the box scene and separate them by a few meters. Instance a laser scene and rotate it and place it so it's facing one of the boxes. Add a camera 3D node to the scene and place it so it's facing the boxes. Add both the sun and the environment to the scene. Increase the length of the raycast by setting the target position's y value to a lower number so that it passes through the box. In the laser scene, on the beam mesh, enable flip faces. Play the scene and you should see the laser stopping at the box. Create a new scene with base GPU particles 3D and rename it end particles. Under draw passes, add a quad mesh to pass 1 and resize it to 0.02 in either dimensions. Under geometry, in material override, add a standard material 3D. In this, set the transparency to alpha. Then, under albedo, set the color to the same color you set for the beam mesh. Then, enable emissions and set the color to the same color as above, and set the energy multiplier to 10. Then, under billboard, set the mode to particle billboard and enable keep scale. Add a particle process material to process material. In this, under direction, increase the spreads to 80. Disable gravity by setting the y value to 0. Add a max and min initial velocity of 1. Under scale, add a curve texture and set it as shown here. Under time, set the lifetime to 0.2. Increase the particle amount to 25. Save the scene under End Particles. In the laser scene, instantiate and end particles and rotate it 90 degrees on the Z. In the laser script, create an onReady variable which gets reference to the child node end particles. In the isColliding if statement, set the Y position of the end particles to the Y position of the cast point. Play the main scene and you'll be able to see the particles at the end of the laser. Create a new scene with a base GPU particles 3D again. Under Draw Pass, set Pass 1 as a quad mesh again with 0.02 in each dimension. Under Geometry, set the material override to a standard material 3D with the exact same values as we set in the previous particles. To process material, add a new particle process material. Set the emission shape to box and set the X and Z coordinates to the same size as your laser and set the Y to a small value. Disable gravity by setting the Y value to 0. Set the direction to just -1 in the Y and set the spread to 0. Set a max and min velocity of 2. Then, under Scale, add a curve texture and set it as shown. Finally, under Collision, set the mode to Hide on Contact. Set the amount to 50 and set the lifetime to 0.5. Rename this node to Beam Particles and save it. In the laser scene, instantiate a child of Beam Particles. In the laser script, create an onReady variable which gets a reference to the child node Beam Particles. At the bottom of the isColliding if statement, set the beam particle's Y position to half that of the cast point's Y position. Calculate the particle amount by having 50 particles per 1 meter of beam. Add this code for setting the particle amount, which makes sure that it's always 1 or higher. Add this further code, which sets the box size to the size of the beam. Now, in the box scene, add a child GPU particle collision box 3D and set it to the size of the box. Now run the main scene and you can see that the beam particles have been added. Now, to add activating and deactivating the laser, go to the laser script and add the variables tween and beam radius set to the radius of the beam. Now, under the process function, add the code for the function to activate the laser. Then, underneath this, add the code for the function to deactivate the laser. In the ready function, add this code to test the activation and deactivation of the laser. If you play the main scene, you should see the laser deactivate and then activate again. Finally, if you want the laser to follow a target, you can use the lookout function. Make sure to set both particles for particle process material to local to the scene. Here is an example of it following a target.